Hello and welcome to our weekly update. Today's December the 10th, and we are going to continue on with our measurement series. The first item on our measurement series is our encryption. Today was the final day for anyone to come forward and try and break our encryption, and the competition was $100,000 to whoever breaks it, and that was supposed to be paid in the lunar sterling. No one has come forward stating that our encryption is as strong as the RSA 1K. Our next step is to make this encryption accessible to the public, and now we wanted to launch with that today, but we still have to finalize our UI. Moving on forward, we're going to talk about the measurement of our development, of our software development, of our design, and from September, October, and 2 weeks into November, we were more focused onto the documentation. And our lead designer, he spent more time entrenched in this documentation, and he said that he felt that development has dropped. And if you look, one way of us keeping measurement of his development, this is contribution to his to the GitHub, and you see in the month of October development has gone down. And that's when our focus was shifted towards the documentation. It actually went down by 14 times less, which brings us to kind of idea we were looking at. It brings us to these user guides, and what these are is these are for whoever wants to launch whatever their satellite, their craft, for any of these rockets. This is Dnieper. This is the Falcon 9 from SpaceX. And if you look inside the required documentation, if you want to launch with any of these organizations or launch on any of these rockets, SpaceX, the Falcon 9, there's only 9 documentations that are required. Dnieper was something in the 20s, and the rocket from Euro Rocket was something like 19 documentations, different documentations needed to use that rocket. So you can kind of see that I think people will be more in gear to using the Falcon 9, because they won't have to stop their production for the documentation. But yeah, of course there's a trade-off because of prices, right? So looking at the historical fact, one of Boris Chertok's books, he said that technical documentation was required especially during the war, when factories needed documentation for the designs of armaments and war items like that, like artillery. Technical documents were required when there was a mass production on an item. Now looking at Korolev, when an engineer approached him and said that we're not going to meet our deadline because we don't have the right design documentation, Korolev would actually go red, because he wasn't producing something in a mass. He was specializing, and he saw that the engineer actually just needed to get his hands dirty and just move forward. And so it's seen there's this struggle between how much documentation is enough or how much is too much, because we saw that our development suffered during our documentation phase. So moving on to the next set of measurement, we have put together a trajectory calculation. And to get the trajectory calculation, what we need is, first we need to know the attributes of our craft. The mass before going into space, and then the end mass when it's on the moon. Then we will need the engine attributes, parameters. the impulses. After that is complete, we would need the starting orbits, right? And there's ways of doing that. After that, we need our target. So we've put that together into our online mission control. Let's start off with the craft settings. Here we'll set the craft total mass, the landed mass, and then we set the engine impulse parameters. Here we have 5 impulse engines. After that is complete, we'll set the initial orbital settings, and then here we could use the 2 line elements to set the orbital settings. We can use the orbital parameters or position and speed. And then we finally get to our target settings. If you see we're actually not going to the orbit, so the 2 line element is grayed out. We are going to be going directly to the moon. And what we've put together is calculation. You'll be able to click anywhere you want to land or specify here. Let's look at it bigger. As you can see, we can come in a little closer, see, zoom in, zoom out. So afterwards we would use the distributed calculation software, a bunch of computers working in parallel to get this calculation, and we will calculate the impulse, the different impulses needed if we're using a liquid engine, or we will calculate the direction of the impulse if we're using a solid state engine. And on that note, that concludes our measurement, and finally, lastly, we will show you some of our experimental work. Here we have, this is, what do we have here? This is copper. Let's see, we got silver here, and we got some titanium here. And you can see that it's in shaven powder form. And using this, these elements, we've put together these metals. And this right here, this is 90% titanium and 10% silver. This is 25% copper and 75% titanium. And this is high-end technology. This is Roman bronze, where this is just copper and an alloy. What we hope to do next is we hope to change this extruder on our 3D printer and start actually printing these guys. With that, what we would need is we will need this oven here, which is also in a vacuum chamber. This is how we made those pieces, and that will be the final state. And that concludes our weekly update. We hope to see you next week.